Hello friends, welcome back. Today I'm gonna do two different examples about force method and indeterminate structure. So I have this frame right here, as you can see. It's a first degree because I only have three equilibrium equations, but there are four reactions. So I have a primary structure, which is it has only one neglected reaction because it's a first degree. So if we can look at this frame, it's going to be determinate, and it has the same forces and distributed loads and external loads and so on. And I find the moment equation for each segment. And for the other structure that I have to do is a first degree structure which has unit load, and find the moment equation for each segment. The equation is delta 1 is plus F1 R1 equals 0. R1 is what I'm gonna find, which is this one. This is the R1 because I deleted it from the primary structure. So delta 1 equals to integration for m capital and m small. M capital is for the primary, and m small is for the structure that I made with the unit load. So I have only two segments because this is 0, and I'm not gonna take this one with it because it's gonna be neglected. And that's for delta 1. Here's delta 1 by calculator. And F1 is the structure with the unit load but squared. So I have this one squared, this one squared, and this one squared. And the integration from 0 to 2 because that's the length of each segment, as you can see. So I substituted, and I get R1 equals to minus 5. Minus 5 means that the direction of this unit load, it's in the opposite. So I'm gonna substitute it here in the original frame. It's gonna be minus 5. And by that I could find these other two reactions easily. I'm gonna deal with this as an external load and find the moment diagram. And for example, I want to clarify this. AI is constant. If it was given, you can substitute it easily. It's not that hard. The second example is a second degree structure or second degree frame. As you can see, here is a fixed reaction, so that's 3 reactions. This is hinge, so 2. That leads us to 5 different reactions, and we have only 3 equilibrium equations, so that means it's a second degree structure. We need a primary structure and 2 other structures that we're gonna put unit loads instead of the deleted reaction. In my case, I deleted this one. You can for example delete this one and put a roller, and then you're gonna put for these two a moment and a horizontal, because that's what you deleted. So for the primary, it's going to be the same structure with the same loads and external loads, but I only deleted this one. So I found the moment equation for each segment and for the other two as well. So I put here's the unit load instead of the reaction that I deleted. Now I'm gonna explain the equation. So the equation is delta 1 plus F11 R1 plus F12 R2, and the other one is delta 2 plus F21 R1 plus F22 R2 equals 0. Delta 1 is m capital and m small for the first structure. So here's the m capital and here's m1. For each segment, you're gonna put the plus sign between them, and you can find the magnitude and put it in the comment below so I can check it for you. And for delta 2, it's m capital and m2. Here is m2, this one. F11 is the first the equation, moment equations for the first structure, but squared, and the F22 is the moment equations for the second structure, which is this one, squared. Each one is squared, and F12 is equal to F21, which is between the first and second structures that I made with the unit loads, and by that I can find the their magnitudes and then substitute them there, and I can find R2 easily and R1 as well. So that's all. It's very easy. You just can practice it and write down in the comments the magnitudes of R1 and R2 for the second example. And if you have any questions, just comment below, or you can contact me. Tell your friends about this video so they can use it before the exam. It has a great knowledge. And by the way, these problems are, one of them is a homework and one of them is 2014 final exam problems. So if you know to solve these, it's going to be very good. Like it and share and subscribe, and thank you very much and good luck.